Correlation versus causation. All right. All of you guys are at school today. The people that are in the room, you're here. All of you within the last 24 hours drank some liquid. I'm not going to even say water, because I know some of you are so addicted to like coffee and drinks from a bottle or whatever that maybe it wasn't water, maybe it was just some liquid. But within the last 24 hours, you drank some liquid, right? So there is a 100% correlation, but it does not mean causation. The water did not cause you to come to school, but you all had the water and you're all at school. All right, so what are you talking about? Correlation just means that they go together. Causation would mean it causes it. Do you think from this picture that the dog probably is the one who tore up the toilet paper? But do you know that for sure? I mean, maybe because they wanted a funny internet picture, the person did it, and they just told their dog to come over and like sit down here and I'm gonna take your picture, right? We don't know that the dog did it. It makes it look like the dog did it, but we don't know if it's causation, but there's a correlation. He's there with shredded toilet paper. All right, so if there's a correlation between two things, then that's called an R value, or that can have an R value. I want you to write this down. R equals 1 is perfect. R equals 0 is none. There's no correlation between the temperature in this room and the price of tea in Shanghai. You agree that there's no correlation between the two? Okay? In other words, the temperature in here could go up and the prices of tea in China could go up, but there isn't any causation. And there probably isn't any correlation either. All right. So if you saw a graph that looked like this, kind of just dots all over the place, do you feel like there's any like correlation between the two things? No. But if you saw a graph that looked like this, do you think that there's maybe a correlation between age and strength? Does it go on forever? No. Once you hit about 25, then your strength starts to slowly, very slowly drop. But up to age 25, you're going to get stronger and stronger and stronger and stronger. I mean, even if you just don't even lift weights, just because your bones are hardening, your ligaments are getting to be a little tougher. So, yeah, those of you that are maybe feel like you're at your peak strength-wise, you aren't. You won't be at your peak until you're like 25. All right. So age and strength, they correlate. Now, does age cause the strength? That's tougher to tell, and we won't ever ask you for that. We will just ask you if they correlate. All right. Now, if you just looked at that graph, you'd have to know that, yes, that is a positive correlation. It's going up. Are there things that go down? Yes, but it wouldn't be like age and strength. Unless it's age after 25 and strength, because then it goes like this. Do you get like a 101-year-old is not very strong? Every one of them? No. But on average, you take a 25-year-old and the same person at 102 years old, and they're way, way, way weaker. It's just fact. You get weaker and weaker as you get older. Okay, so all of a sudden that same thing, age and strength, could be from age 25 to age 95 or something. Your strength goes down. That is called a negative correlation. And since this is really strong, it's like pretty much a straight line with a few exceptions. This might be a negative 0.9. Why is it negative? Because it's going down. All right, I want you to just answer this for me. Positive or negative correlation? Positive. You won't be able to tell the R value, but would you agree that it is less than 1? Because it's not perfect. If it was perfect, it'd be a straight line. See? So this R value might be like 0.9. All right, let's see if you got this. Are they correlated? Yes. Is it positive correlation? No. Is it negative correlation? Yeah. Is it perfect negative correlation? Perfect negative correlation would have been -1. It's not perfect. So maybe -0.9. All right. Now you have to be able to recognize them by looking at a graph. That's one thing. Then I've just covered that, and I'll test you again at the end, make sure you got that. But a calculator is the only way to find out exactly how far off they are from a straight line. See, that's called the line of best fit, and a calculator can tell you how far off all those dots are. And it can tell you, like, oh, that's a 0.6, or that's a 0.5, or that's a 0.8. All right. In this case, since it's going down, it'll be a negative number. And that is found on the calculator, and there's this complicated thing we've got to do, and literally like 6 people messed it up, and then they got lost the rest of the hour. So please, this is the part where I want you to have somebody to look on with. These 2 rows slide next to each other. These 2 rows, except today you were going to stand up and see back here. Slide over. Would you stand up? Actually, we just have a 3 for 3. I'll get close though. So you slide over. All right. Get your calculators on and get to a blank screen. Nice, simple directions. Blank screen and on. This is not the moment to screw around and do something else, because you've got to all do this right so that your calculator works. If you don't do this first little step, it won't work. All right. If I graphed these and you used your calculator to graph it, you'd have to enter all this data and enter all that data. Do you remember what button we used to enter data before? Stat. You are correct. Everybody hit the stat button. Now, the question is, do you have an L1 and an L2 list? Because that's where we would put these. L1 and L2. Now, last hour, some people didn't have the L1 list anymore because they deleted it. And some people entered their data on L2 and L3. Would you please make sure you have L1 and L2? Does everybody have L1 and L2? Because if you don't, I can fix it, but you've got to tell me now. Under Stat Edit, do you all have an L1 and an L2? All right, now, please look on your partner's calculator and verify that, because tons of kids were lying to me. You've got to make sure you've all got L1 and L2. We good? Okay, good. Because if I have to fix this later, I'm going to be ticked because I'm asking you to check with your partner to make sure that they're there. All right. Now, we're going to enter this data on L1 and L2. So this is our data for the L1 list. 12, 16, 16, 18, 13, 19, 11. That's going to go in on L1. Go ahead and type in those numbers right now on L1. And then these numbers that I'm circling in green, those are going to go in on the L2 list. I want to make sure that you're all in a good spot. I'm going to walk around, make sure you know how to type these in. And then I'll tell you how to do the next step. Okay, yay. I have verified now that everybody has diagnostic on. Last hour, a ton of kids didn't, and then they couldn't do the rest of the thing because they were all confused. So now that we've got diagnostics on, do you remember back to we had numbers in our L1 list and our L2 list? You got those numbers typed in? All right. So I think you should take a moment, and if you get the wrong R value here, the R value is like, is this a nice straight line or is it not? It's going to tell you from the R value. Either R is 1 would be like perfect. R is -1 would be like perfect negative correlation. All right, so you're going to all get an R value. If your R value is different than your partner's R value, I would bet you that one of your numbers is just typed in wrong. Like you tried to hit 11 and it only took one of the ones and it's just a 1. You know what I mean? So just make sure if your R value is different than your partner's that you didn't type one of your numbers wrong. All right, so here's where your R value is found. Everybody arrow now to the notes under that page. Find that page in the notes. I think it's page 6. Be careful now. You're going to hit the stats button again. Hit the stats button. Then hit calc for calculate. But there's 2 lin regs. I noticed because one of the kids was doing lin reg, but there's 2 of them. You want the first one that says lin reg. Lin reg AX plus B. This one right here. Now you hit enter a few times, and this screen's going to pop up. Except your R value will not be this. If yours doesn't say an R value, then you didn't turn the diagnostics on, but I saw all of you turn them on. So unless you by accident went and turned it off, you'll have this number, but it's not negative 0.91. Check with the kid next to you and see if their R value is the same as yours. If you got lost, ask him for help. All right, raise your hand if your R value started with 0.8. Raise your hand if it was 0.8 something. All right. So 2 guys in the back. Wake up. Okay, so can you see your R value? Oh, it looks like you haven't done it yet. All right, help him to get to the same spot that you're at. All right. Okay. Good. So, if you were to just be asked, is it positive or negative, is as easy as it seems. That R value that we had, was it positive? Yes. Yeah. So then if you had actually graphed that data, I can tell you it would have looked like this. Would it have been a perfect straight line? No, because it wasn't R equals 1. Now, if you had graphed a perfect straight line, then there's perfect correlation. And there are some things that are like that. Like, they're absolutely perfect. Like, things that are scientific in nature. Like, for example, if you heat something up at a certain pace, the temperature will rise exactly the right amount. You know, like, there are things that'll be perfect, but not many. All right. Your homework is a Schoology quiz. Let's do the first couple of problems together. And let's make sure that you know how to type these in on list 1 and list 2. And the first few questions of the Schoology quiz are super simple. It's like, is this positive or is this negative? Find your Schoology quiz. All right, for that first set of dots, what did you say, Miss Music? No correlation? Why? Explain why. Yeah, nothing's in a line. Nothing looks like you could gather it together in a line this way or that way. There's no correlation, so you just say no correlation. All right, number 2. Marcel, read me number 2.
What is the correlation? Select all that apply.
All right. Would you tell me in words, is it like a dotted, is it like a straight line, kind of?
A little bit.
A little bit straight, and is it going up as you go from left to right?
It's going down.
It's going down, so it's kind of like this?
It's
More scattered a little bit? Good, that's why they call it a scatter plot. Very good. Okay, so then that, to me, means negative correlation. And is that the only thing they want to know? What else they want to know?
If
Ah, okay. So weak, moderate, or strong. Strong would have been a straight line. Is it strong? No. Weak would be like, maybe like this. And none would mean there isn't any correlation. So what would you call this? Oh, moderate. Okay, then that's kind of a judgment call. Why don't you talk to the kid next to you and judge whether you think it's strong, weak, or moderate.
They're all like somewhat.
What'd you say for the?
Good, now do the other one.
I did moderate.
All right. Did you guys settle in on moderate? Or what did you settle in on? Moderate? Okay. Good. Good call. All right. Next, number 3. Let's see. Damien, would you read number 3? A little louder. Was the correlation what?
Select all that apply.
Select all that apply. Okay, so would you describe to me in words what the dots look like?
Basically like the other one just going up.
Okay, so like loose but going up? All right, is it more loose than this? Like that-ish, kind of? Okay, all right. So then, what would you say about it? Is it positive? Yep. Is it strong? No. Is it, well, it's either weak or it's moderate, and then that's kind of a judgment call. If you can barely tell that there is a correlation, then I would go with weak. If you can tell easily that there's a correlation, then I'd go with moderate. Okay? All right. Now let's get to the first one. We got to type in numbers. Everybody, tell me, where is that one? The first one where you got to put in things on L1 and L2.
Question 6.
Number 6. All right. So on number 6, everybody get there. We're skipping a few. It's okay. You can come back to them. For number 6, we got some numbers to put in. And it's got A, B, C, and D. 1, 2, 3, and 4. Would you read me the rest of it, Abby? I got A, B, C, D, 1, 2, 3, 4. And then,
It's 1, 2, 4, 5.
oh, 1, 2, 4, 5. Thank you.
And then it's
Wait. 4, 5. Okay, and then what?
3, 3, 6, 8.
All right, just from looking at this, I'm a math teacher. I could probably figure it out. But if I were you, I would want the calculator to tell me if there's a correlation or not. So I'd type all of these on L1. Remember, they go like this. And I'd type all of these on L2. And then, remember, here's the keys. It's under Stat, Calculate, LinReg. And you're looking for the R value. Okay, so type those in on list 1 and list 2. Stat, calculate, LinReg, and then find your R value. And that should tell you whether there's positive correlation or negative correlation, and if it's strong or weak. Please talk to the kid next to you first, because they can maybe answer your question, unless it's like a theoretical question. Okay, if it's about this specific assignment, the kid right next to you is your first call foul. All right, so for the video's sake, strong is an R value that is between, here I'll put it like this. It's pretty much never going to be 1. It can be. But between 0.65 and 1, that's strong. Moderate is in the middle of that range. 0.35 to 0.65. And weak is where you're between 0 and 0.35. That's how you judge based on the number, whether it's strong, moderate, or weak. Just looking at the picture, it is tough to tell. Strong's easy to tell. It's pretty much a straight line. But moderate and weak, those are harder to see. All right, that's all I got for you for today.